Hello, I'm Jenna.
Hi, I'm Joshua.
I'm Alan.
Okay, so here we have a diagram that shows all of the files in our system. Here we have the science.java. This is where we keep our main method that initializes the program. We have data.java. It's what handles all of our file reading and file writing. Our menu class handles all of the user input and output, communicate so that the user can communicate with the program and select what they'd like to do. Then we have two object classes, the element object or the compound object. The element object represents elements on the periodic table used in chemistry and science. Compounds are a combination of elements. We also have three test classes that we are currently still expanding and adding on to. We have the compound test class, which tests our compound class, element test class, which tests our element class, and data test that will test our data class.
All right, so in our last sprint, we talked a little bit about trying to populate Excel files so that we had all of the elements, and we made it pretty clear that that was not necessary. So we have a method in our data class to handle that whole situation now. So that is our read elements class, and that will populate all of the elements that we had from a text file. And so that will run every single time. And it will create objects in our element class based on all the parameters that we have in the way that that text file is set up. So that will create every single time. However, we also have a similar method, but it's quite a bit more complicated in the compound class, where we are able to create custom compounds based off of the elements that we have previously populated. So in that class, we are able to make a custom name and have as many elements as we want in it, and it will automatically calculate the mass of it, and it will automatically calculate the Hill formula of that as well. And so those were some of the main more used methods that we found that were a little bit more complicated with putting this whole project together. Yeah, so that was fun.
So we started out testing everything manually at first. We tried exhaustively manually testing every single thing that we could until we transferred over to JUnit testing, which is now a lot quicker and streamlined. We have an example of that over here for our element test. This tests our entire, all of the methods for our element class. And as you can see, no errors. 3 failures, oh. Well, that's fine.
You can see here we have this one failed because we've not yet implemented this test. The same with this one, and the same with this one. For the most part, the rest of them have all done well. One of the ones that was particularly more complex is the test, the get mass by symbol. This test, for example, passed an array list of compounds right here, along with a symbol. And to verify, we wanted to make sure that we were actually getting this value here, which is the mass of lithium, and that it would correspond correctly. And we do get a passing test for this one.
For the data test file, I use JUnit to check to see, first of all, if the text file that contains all of our elements was even in the correct place that it was supposed to be. Because if this file was not there, then pretty much nothing would work, because all of our code is based off of the information for these elements. So that was a test I wrote in there just because I felt like it was very important. The test read elements test, it looked in that file just to make sure that we could read and that there was something in there. It didn't go too in depth because I didn't think it was quite necessary, because obviously, again, as we'd run into problems as time goes on if it didn't really have anything else in there. But as for right now, it exists and it can read from it.
As for the reading the compounds, it was very similar to reading the elements, except we ran into the issue that we use the compound.txt to save each compound every time we ran it, to where the list, the compound.txt wasn't actually created yet. So I had to write something to it to check to make sure it would actually read from it.
All right, so now we're gonna give a demonstration of the product and what we have so far. I will go over some of the basic things that we had from the last sprint and some improvements that we have added for this one as well. So firstly, let me apologize for that. Let me try that again. Firstly, we can list the elements. We can choose how we want to list them or whether we would like to filter them. This time, choose the list by atomic number. We've also created is where we don't have to start the program each time, so it returns back to the original introductory list or menu for us. So we've listed here, and we can get all the elements there that we'll be able to use. Now we can choose to filter them. So here we can filter them by state. We can filter by our liquids, and we can see here that we have these, and once again returns back to our main menu. So some of the things that we've done that we've changed is we can now create compounds. Here we can create one manually. I can name the compound, give some instructions on how to do so, just to make sure the user is aware. So we've named the compound. Now I'm just going to enter in random elements, not the actual chemical compound for ammonia, just for an example. But here you can see put in hydrogen. There's 3 of them, and I'll put in gold. We have 5 of them, and I'll put in iron and say we have 6 of those. Whenever I'm done, I can just type done, and here it shows us our compound. So we have the H3 AU5 Fe6 with the Hill formula, and then the mass. We can choose to save this temporarily. By saving this temporarily, it'll save it into an array list that we can pull from, and it'll return us to our main menu. Now, if we would like to save that compound, we can save that compound to a file, and it will exit from the program from here by hitting 5. And now we've saved it, and we can see here that it has saved that compound.
If we had more time in Sprint 3 for this project, we would have definitely liked to look more into unit testing. We learned about it kind of late. I would have preferred to learn about it before everything else, because we're supposed to write tests before designing the software, and it was kind of backwards that way. But I think we handled it pretty decently.
If we had more time, I would have liked to also make some more changes. First of all, like Alan said, Testing has actually been really useful. It just, I think we would have designed it a little bit differently had we had been more aware of how to use JUnit a little bit earlier. Aside from that, I think it would have been really fun to work with GUI. We were hoping to get around to that, but we prioritized functionality over making it look pretty, which I think was probably a pretty good call. But I still like making it look pretty. So if we had more time, I would have loved to do that. However, I do think that we learned a lot. I learned a lot. And I think this class set a lot of uh, a really good base as to the amount of work making a project like this. And I'm sure very complicated projects going forward. And I think this has been a really good guideline to learn. So that's been fun.
And I'd like to add that I agree personally that I wish that I would have focused more on testing early on, learning it and learning how to implement it, use it, because coming in and having to do the testing afterwards has been a little bit difficult because we wrote the methods primarily, and now we're having to write tests around the methods, which I feel like it's harder to grasp what you're really trying to test when you do it that way. Whereas if you know what it is you want to test beforehand, then you write your methods around that, and you can make sure they fit into that that parameter that you have set forth for it. Um, Instead of trying to write tests that pass your methods that already exist, I feel like it's kind of cheapening the experience. Also, I would like to, if I had more time for a third one, I know I would definitely like to work more on some of the functionality for sure, as well as like what Jenna said with the GUI, possibly even. I also wish that I could work to clean up some of our architecture, make it more clear and concise, and having something that's going to be better and last for the future, better than what we have now. Uh, but that's all I have to say. If anybody else has anything to say, if not, it's this has been our presentation.
Thank you for watching.
That's a wrap.